A totally new in-vehicle safety system featuring state-of-the-art technology is now available from Jaguar. The Adaptive Restraint Technology System is the world's first advanced safety system containing world-leading technology. It's been designed by Jaguar to protect both driver and front passenger from many potential crash situations. This leading-edge technology enables Jaguar to tailor specific crash protection procedures for each individual customer within a variety of different scenarios. The system continuously analyzes and updates the position and presence of occupants within the front seat area of the vehicle, and it's the first system of its kind to intelligently decide how best to provide optimum protection for the occupants. At the heart of the system we find the central processor. Here all the information from the various onboard sensors is continuously monitored and analysed. In the event of a crash scenario, the central processor assesses this information and then calculates whether deployment of the airbags is appropriate or not, and if deployment is appropriate, the energy level which should be used to optimise protection. The system has ultrasonic sensors to determine the presence and position of the passenger seat occupant. The sensors transmit ultrasound. Resulting data from this signal is relayed back to the occupancy sensing neural hub. Using artificial neural network technology, the hub assesses if the front seat passenger has moved forward into an area in front of the airbag door known as the deactivation zone. If the passenger leans forward into the zone, the system will disable the airbag and provide a visual confirmation by illuminating the airbag deactivator lamp. For optimum protection, the system is designed to respond only to head or body movements and disregard body extremities such as hands. A silicon-filled weight sensor is located under the passenger seat. This detects distribution of pressure and, together with the occupancy sensing neural hub, informs the central processor of the approximate weight of the occupant present. The driver's position is established using the seat track position sensor. This device, together with the seat belt buckle switch, informs the central processor of the driver's status. This data is crucial to establishing which type of airbag deployment will best protect the driver. The twin output inflation airbags on both the driver and passenger sides operate within 3 parameters. No deployment, first stage deployment, and second stage deployment. The twin output inflation airbag on the passenger side replaces the conventional pyrotechnic device and is a development of Jaguar's heated gas inflator technology. This uses non-toxic stored gas, the residue of which becomes mainly water vapor upon release. The driver airbag is packed in a star fold pattern, enabling the airbag to deploy radially, further reducing the risk of occupant injuries. Throughout each and every journey, the central processor monitors and analyzes data from both the occupant sensing systems and crash sensors. Any change in data is processed and evaluated within milliseconds. With this in mind, we can see how effective the system is within this typical crash situation. The ultrasonic sensors, together with the weight sensors, have detected the presence of a large passenger currently located outside the deactivation zone. The seat track position sensor, located under the driver's seat, indicates that the driver is positioned close to the steering wheel, and both seatbelt buckle switches show that the occupants are wearing seatbelts. The central processor has picked up extreme changes in deceleration data from the front crash sensor and immediately begins a crash severity analysis. Within milliseconds, the central processor establishes that the impact will be severe, and given that both occupants are normally positioned, the seatbelt pre-tensioners are activated and both front airbags are immediately deployed. To summarize, we can see that the driver's airbag underwent a first stage deployment only, and the passenger's airbag was fully deployed to second stage. Having evaluated that the driver was positioned too close to the steering wheel to take a full second stage airbag deployment, the central processor signaled first stage deployment only, thus avoiding unnecessary injury. As the passenger was not positioned within the deactivation zone, it was safe for him to benefit from both first and second stage airbag deployment. In this second crash scenario, we switched around the driver and passenger. The passenger airbag indicator lamp is on, and the ultrasonic sensors have detected head and torso movement within the deactivation zone. The occupancy sensing neural hub has signaled the central processor accordingly. The seat track position sensor has indicated that the driver is positioned quite far back from the steering wheel, and once again, the seat buckle switch indicates that both occupants are belted. The central processor has picked up extreme deceleration data from the crash sensors, and having carried out a crash severity analysis, the seatbelt tensioners are engaged. On this occasion, the driver's airbag is fully deployed to second stage, but the passenger airbag is prohibited from deploying in order to provide protection from potential airbag injury. The passenger's presence within the deactivation zone has caused the central processor to prevent any airbag deployment. The Adaptive Restraint Technology System uses advanced engineering to specifically provide each customer with a tailored crash protection solution. The customer benefits of this new system include optimization of the deployment restraint devices for a range of occupants and crash severities, the reduction in potential of airbag-induced injuries, and the significant reduction in needless passenger airbag deployments, all leading to reduced airbag repair costs. Jaguar have provided the driver and front seat passenger with an advanced protection system that offers the customer a safer solution. Jaguar, the art of performance.